All right, thanks for coming tonight, everyone. I know today was the first day of the Google Dev Summit, so I imagine a lot of you have been watching Tech Talks all day. I'm glad you still have some patience to come tonight and listen to me talk. I'm going to be going over something a little older in Android. Doze Mode and App Standby first came out in Android Marshmallow 4 years ago, but I just recently had an experience on the job using it and decided to come and share what I learned to everyone tonight. So my name is Graeme Campbell. I work at Octave Group as an Android developer. And Octave Group is a music-based company here in Montreal. And we have other operations around the world, but all the R&D is done here in Montreal. And we put out music products under two different brand names. There's TouchTunes, which does jukeboxes. And you may have seen them in some bars around the city. And we also do Play Network, which is background music for large retail spaces. So picture when you're out in a grocery store or shopping in a mall, there's a lot of curation that needs to go into that music, and the artists need to get their royalties, so we provide that service for big businesses. But as you know, if you've been looking at Android for a long time, music apps are always picked as the classic use case for hard background processing and when you want to do foreground services to keep everything running. So that is what we do there. So what is Doze Mode? It has one goal, and that's to preserve the battery life. Because back in the old days, if you take a look at the screenshot here, this was from Lollipop, and this poor person had some kind of problem going on. You can see the cell signal was going full speed. The Wi-Fi was on almost the entire time, and there was wake locks the whole time, and the screen was hardly on. So this poor individual lost their entire battery's charge in less than 8 hours, and that's the way things used to be in Android. Running in the background was completely wide open. Anybody could do anything. So 4 years ago, Google decided to start doing something about it. And they provided us with Doze Mode and App Standby first. So the idea here is you want to limit this background processing, and the very first thing it does is it suspends the network. Because that radio, when it spins up, it is just throttling the battery. And every app is requesting the network all the time, willy-nilly. So they decided that they were going to limit that. And there's a few other things they do. They ignore your wake locks. So if you're trying to run the CPU nonstop, that's stopped. And then other background jobs, such as Alarm Manager, Job Scheduler, Sync Adapters, and Work Manager, they don't get canceled. What happens is they get deferred for later. So Android will batch them all up and run them all at one time for every app on your phone. So the best way to see Doze Mode is with this graphic that Google has provided. On the left there, where it's looking like a barcode, that's the user using their phone, screen's on, they're browsing away. And then at the first black line, that's when the screen has been turned off and the phone's been put down on the table. So these are the things that Doze Mode is. It's got to be when it's on battery and stationary. So for the first little while, in that little red box, it's still doing all of its background processing. But after a certain amount of time, it starts that batching up that I was telling you about. And you can see here, no wake locks, no network access, all the deferred stuff, and also no GPS scanning, because that's also using radio. So when it's in that little green bar, that's when it's saving your battery. And every once in a while, it'll come up to a maintenance window where the device awakens, it lets every app run all of those deferred jobs, and then it goes back into Doze Mode and it saves the battery for a while longer. Key things to note here are the green bars get wider every single time. They're using an exponential backoff to make sure that if the phone's resting for an entire day, it has those maintenance windows less and less often, so it's preserving battery as much as it can. And then we also have App Standby. So if Doze Mode is for the entire device, then App Standby is on an individual app level. So again, the device has to be on battery, because if you plug it in, App Standby ends. And the app has to have been not used for a while. There's a few, actually, circumstances. App not used, you've got no foreground services running, you've got no notifications on the lock screen or in the notification tray. And in that situation, your app may be decided by the operating system to get put in standby mode. But there's a few circumstances that won't happen, like device admin apps. They won't be put in standby. Your telephony manager, that's not going to happen, right? And you can also whitelist an app to make sure that the OS never puts it into standby mode. So back to our poor friend with the battery problem. The 6.0 version of Doze Mode, it does help, but it's either fully on or fully off. And it takes a long time to turn on. That first doze, sometimes it would be maybe up to 2 hours before it kicked in. So if you look at the time down at the bottom here, after 2 hours, this guy might have lost 30% of his battery already. And the other thing is it only turns on when stationary. So to address those problems, in Android 7 Nougat, we got some new features. There was extended doze and light doze. Extended doze is also called doze on the go. So that's when you're not using your phone, it's in your pocket, you're walking around, but you're not looking at it, so they still want to save your battery some. And they put out some kind of like a lesser doze mode. And kind of like a cousin of that, we've got the light doze. So light doze, instead of being all on and all off, first the device will go into a light doze mode for a while, and then after a while, maybe about an hour or so, it then kicks into the deep doze. This table shows the difference between the original doze and the extended, but I prefer to jump straight to the graph. It looks a lot better this way. So again on the left, we see the barcode where the person's using their phone, and then they lock it, and it emphasizes that it's not stationary. So that's put in the pocket, walking around. If you take a look there at some of the things that you're still allowed to do, wake locks. Wake locks are still okay. If you need that CPU for something, maybe you're running a fitness tracker app, you want that to keep going. The alarm manager stuff is not deferred, and GPS and Wi-Fi scanning, that's still allowed to go on. Of course, you're walking around, you want to know where you are. Now, this will continue until the person turns the screen on or plugs it in, and then extended doze mode ends. And the cousin to that is the light doze. So here we see, similar to the first image, but you can distinctly see a difference between the light doze mode and the deep doze mode. And it's also important to point out, those light doze windows, they're much, much shorter. And the maintenance windows are much more frequent. And then after a while, it says, okay, this person's not using their phone. So it goes into the full deep doze, just like Android 6. So here we have a little bit of live world data. I hope you can read that. I apologize for the wall of text. But this is something that you can actually get yourself on any device that you're running. And by running this ADB command, ADB shell dump sys device idle, it gives you a huge amount of stuff, and within there, there's the idling history. And I took the screenshot of my battery usage on the right just to compare what it looks like when you're, we're all familiar with the graph inside of Android, but that's what it looks like in the background when it's going into all these idle modes. So you can see it doing light idle and light maintenance. And then at one point it goes to motion. That was where I was sitting there watching a video for an hour and the app was fully awakened. And then when I put it down, it went back into light doze, and a little while later I opened up the screen again, and then that last little period I left it overnight. And if you could see the numbers, you would see that the period is getting much, much longer. Instead, I put it on a table for us, and you can see how it was doing the 1 hours, the 2 hours, the 4 hours, and the 6 hours. That was a full 6-hour span between maintenance windows. And the other key thing to note is just how short the maintenance window is on light doze. It's going to go for just 5 seconds. But when you're in deep doze, it's going to be a full 30 seconds, because that's letting all the apps on your phone do all their synchronization. So these are some of the strategies that Google has provided to us to actually test Doze Mode on a device. It's the easiest thing to do is to trigger these commands with ADB, because you don't want to be sitting there waiting for your phone for 2 hours. You got apps to test. You got to push it. You got to ship it, right? So when you're testing this, you want to do it fast. And the first command you see there is this battery unplug. That doesn't actually kill the battery. You can have your phone plugged into your computer so that you're doing these ADB commands. And it is still getting a charge from the computer, but the operating system on the device thinks that it's unplugged, so it's still going to behave like you were in Doze mode. So we have this one command, the device idle step, and that'll step deeper and deeper into Doze mode one by another. And finally, if you're doing a different kind of testing, those last two commands on the left, force idle and unforce, that'll let you put the whole thing directly into Doze mode, and it'll work like that when the app is in use, right? So you can really see how it's going to behave in the background. Now, App Standby has its own set of commands for working with. Again, we're going to want to do the battery unplug. And here we use the activity manager. So we can tell the activity manager, set inactive, and then you put your app's package name in there, and you go true and false to get it in and out of inactive mode. And without a Boolean operator there, it will just tell you whether it's in standby mode or not. And I'm going to show just some actual results of testing this on the device. So at one point, I plugged in my phone and I hit device idle step, and it tells me it's active. I did it again, and it still says active. So at this point, I realized, okay, I've made a mistake. Either the phone is on, or I forgot to run this battery unplug command. So indeed, it was the battery unplug. I press that, and then the next time I say device idle step, it goes into idle pending, and then sensing and locating. I don't know what those are. But finally, we get into idle mode. And how I would test this in the real world was I would set up all my stuff that I wanted on the phone. I knew something was going to trigger in a minute, so I would get it into idle mode, and then I would watch the logs on Logcat and see if it was behaving as I expected. So oftentimes I would see my thing try to run, an alarm manager comes up, and it goes into a deferred state. And then if we run device idle step again, we get idle maintenance. So here is where you'll see that maintenance window, and hopefully you should see all your queued jobs going. And if we do device idle step again, it goes back into idle mode, and it will just cycle between these two, idle maintenance, idle. And the only way to take it out of Doze mode is just like the real world, either plug it in or wake up the screen. And one little reminder, if you're testing it with that battery unplug command, you're going to want to do battery reset when you're done, because it's going to stay that way until you reboot it. So there have been so many times I thought, what's wrong with my charge cable? Oh, I forgot I was testing earlier. So now let's talk about ways to get around Doze mode, because when your app is not responding, that can be a real killer use case for some people. So if you absolutely need to get commands into your app, the best thing to use is Firebase Cloud Messaging. So let's say you're writing a instant messaging app, and somebody sends a message, hey, you want to go out for drinks? We're getting together in 20 minutes. If you're in a 6-hour Doze window, you do not want to miss that message. So Google will allow a high priority message to awaken the app. If it's a normal priority message or low priority, they will just queue it up like most other things, and it'll wait for the maintenance window. Now, Alarm Manager has had this method called setExact since API 19. And when Doze mode came out, they gave us a few other methods to work with. I like the setExact and allow while idle. It behaves as Alarm Manager, as you would expect Alarm Manager to behave. It triggers at exactly the right time. But remember, Alarm Manager, you have no network access. So the last thing we can do to get around Doze mode is whitelisting. But whitelisting is kind of a tricky situation. Now, all of us can do whitelisting right now. Your device has the battery optimization settings. You can get in there and you can pick an app that you want to behave all the time as you expect, and you can turn that on. Now, as developers, we can actually write code to request this. So the first one there is an intent. It's going to launch the battery optimization screen, just like the screenshot, and the user can whitelist your app there. And also, if you'll recall, in the Marshmallow API, we came out with a new permissions paradigm. So if you use this request ignore battery optimizations, it'll pop up a little window. The user can say, yes, I want to whitelist your app, and good to go, right? Wrong. This is actually something that is, it's a real tough situation. Google has put out a list of things that or situations that you're allowed to request whitelisting. And it is very strict. So I took a look online here, and they have a kind of sample use cases. So if you're doing an instant messaging chat app and you've got FCM in that app, that is not acceptable for requesting a whitelisting. And maybe, the second one on the list here, there's a voice over IP application, but they can't use FCM for some other reason. Okay, that's acceptable. And then they talk about task automation and peripheral devices. But for a music company, we didn't fit in any of these situations. And what I was seeing online is that, Google, they want to make sure that that Doze Mode is respected across the entire ecosystem. So there have been cases of apps being deleted from the Play Store because of requesting these things inappropriately. And I thought, you know what? This is not the kind of thing I can put in my app. I don't want to be that developer who got us banned, right? So I realized I need a new strategy. And coincidentally, that's around the time I started thinking, maybe this should be a GDG talk. So here was the real-world situation that we encountered at Octavio Group. We had a list of requirements from the business, and they were conflicting. We absolutely needed to use the alarm managers, set exact and allow while idle, because it needed to come on at an exact time. But that alarm manager code also needed the network. So, as you recall, Doze Mode blocks the alarm manager. We thought about this for a while, and eventually we came up with a workaround. So luckily, in the Power Manager, we have this method, isDeviceIdleMode, and it'll return true or false. So we have a way of knowing if the device is sleeping. If it's true, we launch Work Manager as a backup. So here we have the actual Alarm Manager code. Alarm Manager is pretty old in Android. We're supporting devices earlier than Marshmallow, so in that case, we use the same old setExact method as before. And for the newer ones, we run setExact and allow while idle. Everything there is the same. What was different was the next screen, where we're actually processing that alarm. The first thing we do is make a call to the Power Manager and ask if we're in device idle mode. And if we are, if we're not in device idle mode, we just go right ahead and do the network stuff call. And that's a long-running operation. We can trust it's going to go down fine because the user is actually using the app, or it's only been sitting around for 10 minutes. But otherwise, we will launch a Work Manager request. So you can see here, we are setting some constraints on there. And if you tell Work Manager that you have this constraint that the network has to be connected, that's the trigger to the operating system to batch your job up and wait until it's in a maintenance window. And when the maintenance window comes along, it calls our Doze Mode refresh worker, and there you can see that we're doing do network stuff inside the long operation. And yeah, that worked just fine for us. We were able to satisfy the business requirements and have a backup strategy for those cases where it was in Doze Mode. And we didn't want the user probably didn't want us doing anything anyways. So as soon as the device came back, they got their network requests, and it was a pretty seamless experience. So this is kind of like a decision flow chart for the current state of Android development to figure out what strategy you're going to use when you're going to do some background processing. If you're just doing some local work and your time isn't too stringent and you can defer it, go with the Work Manager. But if this is something that has to be triggered online, you've got your Firebase cloud messaging. Now, the Firebase message, it will awaken your app. And what if your app needs to use the network? The device is still in Doze Mode. So Google actually suggests to do a workaround similar to what we did with the Alarm Manager. And the Firebase cloud messaging, it awakens, it sets a Work Manager to do its work in the background. But if it was a very critical message coming through, then you can set the notification right there, and the user will get their stuff. So the next decision tree was, does it need to execute at an exact time? Alarm Manager, like we were using. And the final one, if the user expects it to run immediately without interruption, it will guaranteed go to completion. You're going to want to use a foreground service. And if you're saying no to every one of these questions, then perhaps background processing isn't what you want to do, and you should just do it within your app itself. So far I've only talked about Android 6 and Android 7. Those were Doze Mode and then the extended versions that came out. But the background processing restrictions have continued to evolve with every version of Android. And I think each one of these could be their own topic. So I just wanted to briefly go over them and let you know they exist. On Android Oreo 8, suddenly there was restrictions on background services. An app running in the background cannot launch a background service. They can launch a foreground service, but if you try to launch a background service in the background, there will be a ANR. And this is to prevent, malware from getting its roots in your app, in your system. And the other thing on Android Oreo is it would limit the implicit broadcasts which an app can wake up to. You now have a very short list of things that you're allowed to listen to from the operating system. And then in 9, we had a few more features that came out. There was adaptive battery. And adaptive battery is like an evolution of App Standby. The old App Standby was just 2 states. Your app is either active or inactive. This one adds a few more states, and it's got a machine learning algorithm to decide when your app should be put into which of those states. It's a pretty complicated topic, and fortunately it hasn't hit us yet. And then the other thing that came out last year with Android 9 was the app restrictions. Some of you may have seen that on your phone. If you've ever looked up and said, got a notification that something is using a lot of battery in the background, do you want to restrict it? So yeah, the user can say, yep, I want to restrict your app. And now with the latest version of Android that's just come out, we've got a few more things. There's apps are no longer able to start activities from the background. So something is not allowed to just pop something up on your screen. Those of us who don't like adware, that's a great feature. And the other thing is that if you want to access the device location in the background, now you explicitly have to ask for permission for that for the user. And if you think about it, these Android 10 changes, they're really less about battery optimization, and they're more about user annoyances. But, I think the writing's on the wall. It's becoming far more important to make sure that when we release the first version of our app, we have all the background processing as seamless as it can be, because you only get one chance to make a good first impression. And if your user is getting annoyed and seeing all these things, they can say, yes, restrict it. And that restriction is probably permanent. So, we got one chance to give them a good user experience, and that's good for everybody. That's good for us as well. Our phones last longer. So that's it for me tonight. Thank you very much for coming. Anybody have any questions? Okay, thanks very much.